video is going to focus on polyatomic ions. What polyatomic ions literally means are many atoms. So what these are is they're a group of atoms that tend to always show up. They're like covalently bonded together, but they either take on extra electrons or lose some electrons to become charged. So they're poly because they have multiple atoms that are bonded together covalently, but they're an ion because they have charge. So these were the ones that showed up in Lewis dot, where we had brackets with those extra charges on the outside. Because they showed up all the time together, they ended up with their own naming conventions that always end in ate or ite, except for the few times that they don't. So luckily for you, you don't really have to memorize these because we give you the polyatomic ions that we want you to know on the back of the periodic table, okay? So from here on out, when we have an ionic compound, we'll have a metal, as always, or you'll have ammonia, which I'll show you in a sec. And you'll either have a non-metal that ends in "ide," which means it's hydroxide, cyanide, or an element from the table, or it'll end in "ate" or "ite," which means it's a polyatomic ion. Okay. So your polyatomic ions are on the back of the periodic table. Here's a group of them. Essentially, if they show up in a naming scenario, they are what they are. So if I say I have iron nitrate, nitrate is NO3 minus 1. I would use it the same way I use any other single atom. Okay. Now, while there's this set of polyatomic ions you should be familiar with, there are these additional rules at the bottom of our table that make it so this list of polyatomic ions is actually much bigger, because I could take any one of these names and I could change it slightly and that would become a new ion. So for example, on this table right now, we have nitrate. But if I was working on a naming scenario where I had nitrite instead, nitrite means I have one less oxygen. So when I have the nitrate with an ite ending, the nitrate that I have up there is the same, except it has one less oxygen. Charge doesn't change, just the number of oxygens. If I was given something like per sulfate means one more oxygen. So per rate 8. So per sulfate would be SO5, still with a 2 minus charge. If I have a hypo, so let's say I have hypochlorite, okay, hypoite. Hypochlorite is 2 less oxygens. So the 3 oxygens goes down to 1, same charge. If you see a if you see an ionic compound that all of a sudden has a hydrogen shoved into the center of it, that just means the name is hydrogen polyatomic. So sodium is still sodium, but this HSO4 would actually be called hydrogen sulfate because the hydrogen becomes part of the polyatomic ion. That also means hydrogen sulfate, this whole thing has a charge of the +1 hydrogen plus the -2 of sulfate. So this whole polyatomic ion has a -2 overall charge. That's a little complicated and something you're definitely have to work with in practice, but that's sort of the naming system, how it works. The rules of how you do ionic naming is the same as the rules from the last video. Nothing changes. It's just that the anion now is a polyatomic ion. So here's some examples. If I was dealing with calcium nitrate, I would write down Ca, which is calcium. Nitrate ends in 8, so I'd look at the back of my periodic table. Nitrate's NO3. Charges then, calcium's a +2, nitrate's a -1. So I need 2 nitrates to make this work. Now you don't just pop a 2 out there because that now makes it look like I have a 32. So for polyatomic ions, you sometimes need to use parentheses to show that this whole group is occurring twice. So nitrate is nitrate is nitrate. I can't like change this 3 to something else because that would make it not nitrate. So when I need more than one of my polyatomic ions, I use a parenthesis like that. Next one is nickel, which is Ni. Carbonate, if I look at the back of my periodic table, carbonate is NO3 minus 2. So carbonate is CO3 minus 2 still. Okay, so that's CO2 is the compound I'm working with. Nickel's plus 1 because of the because of the Roman numeral. Carbonate is minus 2. So again, I need 2 this time of the nickel to neutralize those 2 charges. Now I don't need parentheses on the carbonate because I didn't need more than one of them. So a Roman parentheses not needed. Next one, scandium, which is Sc. Hydroxide, this is still a polyatomic ion. It's on the back of my table. It's OH. Scandium's a plus 3. Hydroxide's a minus 1. You can't just throw a 3 at the end because that means I have 3 hydrogens but not 3 hydroxides. So you need a parenthesis with the 3 down there at the bottom. Silver is Ag. CO3 on the back of my table is carbonate. Done. Silver doesn't need a Roman numeral. Fe is iron. SO3 is 1 less than sulfate, so that's sulfite. Sulfur is always a minus 2, so given the formula, iron's a plus 2. Mg is magnesium. Now this one's a hard one because ClO is your polyatomic ion. It's happening twice, but ClO is what I'm naming. ClO is actually this 2 less oxygens than chlorate. So this is hypochlorite, which is challenging for most people. No Roman numeral needed though because it's magnesium. So here's where it starts to get difficult now that we have polyatomic ions. You have all these endings you now have to pay attention to. Ide means periodic table on the front, single element. 8 means it's listed on the back. Ite means this rule, 1 less oxygen, same charge. So go ahead and try the quiz for this and have a nice night.